Welcome back, everyone. This is Blue Dolphin with Hoplite Security, and we're going to be jumping into the Hack the Box late machine. So starting off with a high-level overview in under 30 seconds, we start off with enumeration. Of course, we do some web enumeration, learn that we are dealing with the late.hackthebox host. We then do some subdomain enumeration and learn all about the images.late.htb web page, which has a web app that does file conversion. We play around with this. We learn about a server-side template injection. We then enumerate various SSTI payloads. Eventually, we get command injection, which allows us to capture a SSH key from the service account, which we use to log in. This gives us the user flag. Once we're logged in with the user flag, we do some internal enumeration. We notice with linps that there is a SSH Alert script running. We do some work. We learn about the append attribute, which means we can actually modify this file. So we append it with a reverse shell, and with PS spy, we realize that root is actually also executing this script. So we put a bash reverse shell in there, wait for it to trigger, and we get a shell as root. That's it. Let's get into it. Jumping right into things here, we're going to start off with our nmap scan as usual. We can see that we just have port 22 and 80 open, fairly straightforward. We'll jump right to the internet browser here and browse to our target, which is 10.129.227.134. And on this landing page, we initially look around, and I believe some people had used directory busting to find out there was a subdomain. However, we can see down here that there is under the contact an email, support@late.hackthebox, but then there's also this free online photo editor that we will click and it will, so if we just hover the mouse over it, even on the bottom left, it says images.late.htb, but if we click it, we can see it tries to bring us to the domain name images.late.hackthebox or HTTP. It doesn't work. And this is because we have to add this to our Etsy host file to force the route. The way we do this is with sudo nano Etsy hosts. And I already have the entry in here from when I completed this. So I'm just going to modify it to our current IP address of the target, as this is a new instance. We'll save this, reload the web page. We land on this web page, and we will start off by enumerating it using Burp Suite. Now, originally, I was unsure of what direction to take if I was looking for a server-side template injection or cross-site scripting or a file upload vulnerability. I wasn't quite sure. However, after just talking to people in the community and poking around a bit, it became clear that there was obviously a server-side template injection. So the way that I kind of found this out, once I was pointed in the right direction, was by spinning up Burp Suite and uploading a file. So let's do that. Because this application says convert image to text with Flask, we do know that Flask relies on Jinja for templates. If we are dealing with server-side templates and a situation where we would want to use server-side templates, or as a developer, if I understand correctly, is you want to render everything server-side to save time and to be more efficient and organized than having things rendered client-side. Now, the description does say we turn an image into a text document. This makes me think we want to pass to it an image with a letter to see if it captures that. I've just pulled up a list of letters here on Google, and we're going to take one at random here, save this, and upload it. So this will be images.png. We'll jump over to the image reader and just pass it, images.png. We'll go ahead and click scan image. We will hit open with, and so nothing actually worked here. That's fine. Let's go ahead and spin up Burp Suite and try this again. Slight correction here. I don't even think we need Burp Suite. I believe we could just do this simply by creating our own text file and screenshotting the letters. So I'm going to go ahead and jump over into the late directory. And we're just going to go nano character.text. And what we'll do is I actually had to play around with this a fair amount the first time. And it took me a bit until I had some success, just because I literally had to zoom in when taking a screenshot of a letter and uploading it as an image. So here I'm going to zoom in. We'll have the letters A, and I will move the cursor. And for this part, I actually used Flame Shot, which was like a snippet tool, but for Linux. And we'll take a screenshot, just like so. We will save this screenshot. We'll call it a test. And then we'll go ahead and just try uploading it. And if this works, we should see this in the results. So it didn't work. So let's go ahead and make the characters a little bigger. We'll zoom in. There we go. I bet this will work here. Okay. We'll call Flame Shot. Grab this again. Save it. Call it a test. Upload, and we should see some success. We don't see any success. All right, let me try. That's odd. Let me try just doing, maybe I have to do different characters and zoom in a little more and make sure the background doesn't have any colors that are interfering. So I will do AOD and I'll zoom in even more. I don't know if I can really zoom in anymore. Let's try this again. I'll take a bit of a bigger screenshot. Save this, call it a test. And let's try uploading it again. It's weird it's not working. Let me try. That's weird. Okay, let's try again. I've just zoomed in to make it a little bigger here, and I think this should work. There we go. Okay, so it finally worked. We see AOD here in the results.txt. So this tells us that it is indeed looking at our image, identifying characters, parsing those characters, and returning it to us in a text file. So the way to detect or enumerate for an SSTI or server-side template injection is to use this fantastic workflow, which I'm pulling up right now. This is the flow map on Hack Tricks. If you don't know about it, definitely check it out. Tons of awesome resources. And it just has us follow these paths here for enumerating for server-side template injection. So if we actually try creating a text document with this test payload, what will happen is with server-side templates, if I understand correctly, the parentheses denote a variable. So for example, if you had, say, an application, you could have a form, and when a user fills it out, instead of asking them for their first name, you could have in that template parentheses, first name parentheses, and the template would actually pull that first name from somewhere else based on the user, whether it's a cookie or they're logged in. So it would be a variable that could always be changing. Or maybe you're sending out an email, a mass email, and you want to use a template. You could put in there, in the body of the email, you could say greetings, parenthesis, first name, close parentheses. And then for every person you're emailing, it would just pull their name from the email and put it in there. And what's happening in this case is if it's not sanitized properly, it will actually execute arguments or expressions. So what we'll have in this case is a math equation. And if this math equation returns 49, then we know we have server-side template injection. So we're going to go ahead and try that here. We'll just delete AOD and we will go parenthesis, parenthesis, 7 times 7, parenthesis, parenthesis, get a screenshot. Oh, I want to get the cursor out of there, or that might cause some confusion. Now I do find that I have to actually play around with the size of the screenshot, just in the sense of how zoomed in it is on the character. So I had to do this about 5 or 6 times with just taking the screenshots very big, little smaller, maybe more narrow until it worked. So hopefully I'll get it on the first try here. Let's find out. We'll do ssti.png. We'll jump over to the image reader and just upload ssti PNG. So look at that. We got on the first try. So it says 49. So it actually took the characters here and processed this as an expression and performed the equation. Now, from here, what we would do is we know we're running the Flask application. So we'll simply Google Flask SSTI. And there are several places that we can go to find payloads, but one of the really good sites that was recommended to me was Payloads All Things, or I think it's All the Things. And I know IPSec always uses Payload All the Things and highly recommends it, and he's an expert, so I'm not going to deviate away from anything he recommends. And he's right, this is a fantastic resource. If we look through here, we'll see Jinja 2. So Jinja 2, of course, is the default template engine that's used with the Flask Python web application development framework. And we will click on the remote execution. We'll scroll through here. And the first thing I went for was this shorter payload, which is just says Sickler, initiate globals, OS, open ID, read. So let's copy this. We will now paste this in here. And what's going to happen is we're actually going to get some errors. So I'll kind of show everyone how I got through those errors. What you have to do and what I did there's a bit of a difference here. Initially, I honestly had to play around for quite some time and I wasn't really sure what was going on, but I'll show you the error and how to fix it right away instead of going on this long convoluted journey that I did of playing around with all the characters, looking for bad characters that didn't exist, so on and so forth. So what we'll do is I'll take a screenshot here. We will copy this and save it. And we'll call this payload. We will attempt to now upload this. Hopefully it works. Oh, it just worked. Okay, well, the first time I tried this, it didn't work. And what I had to do eventually was delete the white space here from the parentheses to the commands, and it worked. Okay, well, yeah, so obviously, this is working. And you can see that the web application is running as service account. What we'll do now is the path forwards is to get the SSH key from the service account. So quite simple, we just replace ID with cat. Let me think, it will be home SVC account .ssh /ID _ RSA. Now we want this to fit in the screen, so I'm going to do a couple backspaces here, maybe even zoom out, which I don't know if that's going to cause problems. We'll find out. Hopefully not. But we almost have everything fitting in the screen here. Okay, we'll do another zoom out. So actually, let's see if I can just make this terminal a little wider. There we go. Okay. We'll go ahead and take a snapshot here and hope this works on the first run. Hopefully these background letters don't cause issues. I think they will. Let's just give it a shot though. So we'll call this payload updated. We will pass this to our image converter. Okay, it worked. So that's cool. All right, let's go ahead and copy this private key. And we will use this to access the box. We will zoom out. We don't need to be zoomed in anymore. And we will just do nano ID _ RSA. Paste the RSA key, and we're going to remove the P, the tag there. All right, we'll save this. And we need to change permissions to 600. Perfect. Now we will do SSH-I to call our key, and it will be svc_acc at our target 129.227.134. This should work. All right, and we are in as user. So this would let you cap the flag, which is right here, user.text. All right, so let's go ahead and jump into the privilege escalation phase. The way we're going to do this is by uploading linps and starting with that. I have here a Python simple server spun up with the linps.sh and pspy64 binaries and the script. So what we'll do is we'll make a call to get linps from our target, and we will go wget http 10.10.14.75 will report 8000, so that's the default port, /linps.sh. Awesome. And now we're going to go ahead and run linps. Oh, first we have to change the permission. So we'll go change mod 777 linps.sh. There we go. And now we will run it. All right. So linps has finished running, and let me just zoom out here a little bit. Zoom out. And I'll make this full screen. As we look through this, what we're looking for in this case, there were several things. Some things I thought were interesting, but what really stands out is the under here user local sbin ssh alert.sh. Now, obviously, we're going to go and have a look at exactly that. So let's jump over to user local ssbin, because that's not normal for a default ssh alert to be there. So we'll go cd change directory user sbin local, or was it I think it's local sbin. Whoops. And then there's our SSH alert. So if we review this, what I understand from this is it's we're emailing root, and we're just saying the subject is email from server login. So it's an SSH alert. You SSH in, this email fires, and it just says an SSH login was detected. And here it's using privilege access management to manage identity access on the device. And it's just letting us know who logged in and who connected. And that's great. What's really important, though, is if we go ls-la to look at the permissions, we can see that the user, so service count, has read, write, execute, and the group, anyone in the group for this script has execute and read, and everybody else has execute. So that means root could execute this. But if we do sudo-l, we can't execute it as root because we don't have a password for the service account. Well, the solution here is to call over pspy64. And this will let us see that root is actually calling and executing this script. But before we do that, something I learned that was interesting, I didn't know this. I actually just went right to try and edit the file because we know we can because of the permissions. We have read, write, and execute. I learned that we can type or do list attributes. So it's LSATTR. Right. And here we can see we have A, and I guess this means we can actually append the file, which is super cool. That's something new that I did not know. Sorry there, my cat was just running around and being funny. All right. What we'll do is we'll just jump back over into our home directory here, and we will call, or into our service account directory, and we're going to do wget http back to our server 10.10.14.75 or report 8000, and we're going to call ps or pspy64, and we are going to run. Oh, first let's change permissions as always. Now we're going to run pspy. All right. It's running here. It just provided us with a fair amount of information, but in here we don't see what we want right away. So what we have to do is actually log in with an SSH connection, because that's how the SSH alert script fires, is you log in with an SSH connection. So we're going to go ahead and do that by creating a new tab, jumping over to our Hack the Box late folder and going SSH-I IDRSA service account at 10.129.227.134. It's going to let us in. Great. Now we'll jump back over here and let me just rename this so I don't get confused to PSPy. Oh, sorry, that was our server. So I'll just call this pserv. And if we take a look here, we can see that, so the user ID here 0 is going to be root. And we can see here, copy root scripts alert SSH, user local sbin alert SSH, change permissions on it, change ownership, and then down here, it just executes. Root just executes ssh.alert. Okay, easy enough. What we'll do is modify that. And the way we'll do that is simply by adding a reverse shell to the very bottom of the script. So let's go ahead and do that. Let's go to user, or we'll jump in the root directory. There we go. We'll user local sbin. We'll see our SSH alert there, and we'll just go nano SSH alert. And we'll add a bash reverse shell to the very bottom here. So this will be bash I and dev TCP, our IP address, our port, and we'll save this. Can we even use nano to do this? I think I echoed it in the first time. Continue saving, yes. Error writing, operation not permitted. Okay, because right, we're trying to append it. So that was a waste of time. All right, let's copy this reverse shell here. Now I want to exit this without actually killing my shell. Perfect. So let's go ahead and go echo double quotes our reverse shell. And then we do 2 greater than signs to append. If we did 1, it would just replace everything in the file. And we'll call this to SSH alert. Now we'll cat that just to make sure it's there, and we see a reverse shell there. So now what we'll do is we'll create a listener, and we'll literally just call this listen, and we'll do netcat no DNS lookup listen verbose port 6363. I'm actually going to change this to just call it SSH to clean up the tabs. Awesome. What we will do now is let me move our Python server out of the way here. You can see this is our PSPy running. So what will happen is we will disconnect, reconnect. We should see that in PSPy, and then that should execute and give us a reverse shell. Let's go ahead and do that. We'll take our SSH connection and terminate it. There we go. And we'll connect back in. Quite unfortunate. It says that the connection's closed. Well, oh, never mind. I guess we got the reverse shell anyways. Who am I? Root. Perfect. All right. So if you look there, you can see that if we jump into the root directory now, we have our root.txt. So that's a wrap. Thanks everyone for tuning in. See you in the next Hack the Box machine.